In this video, we'll take up where we left off after building our player mechanics in the last episode. We'll add enemy effects like movement and explosions to our game. To trigger the enemy explosion, we need to create a collision. A collision occurs when two game objects with a collider component attached run into each other. We will create a collision handler that destroys the enemy upon hitting it and trigger the explosion animation in that handler. Start by adding a Circle Collider 2D component to our projectile by selecting the game object in the hierarchy, navigating to the inspector panel, and clicking Add Component. Add a Circle Collider 2D and make sure to enable the trigger variable on the Circle Collider 2D component. As you can see, the enemy now has a green circle around the outside of the game object, representing the collider. Next, create a new script called enemy by right-clicking in the project panel, navigating to create and selecting C# script. For now, this script's responsibility will be to disable the enemy object after collision. Attach the script to the enemy game object. Let's also create a new tag for our enemy. A tag in Unity is a reference word that can be assigned to a specific game object. We will be using tags to determine what object our projectile hit, along with a few other uses in coming episodes. Select the tag dropdown in the inspector panel of our enemy game object and select Add Tag. Click the plus icon, type enemy, and click Save. Now select the enemy game object again in the hierarchy panel, navigate to the tag dropdown in the inspector panel, and select enemy. Double-click the enemy script to open it in Visual Studio. First, let's create a new public void function named death. All we need to do is destroy the game object when this function is called. So let's call the destroy function with the parameter game object, which will destroy the game object this script is attached to. Now let's create the collision handler by opening the projectile script. Initialize the private void function on trigger enter 2D. When our collision occurs, the Unity game engine will call this function for us, taking the projectile we hit as the parameter of the function, here simply called collision. Now let's test and make sure our collision is working. Before we get started with the explosion animation, let's start with the enemy movement, which is the easier of the two animations. To create the animation, we'll be using the timeline feature built into Unity. The timeline tool allows us to control our game object's position at specific times during our animation, that when sequenced together, create our animation. First, let's create an empty game object by right-clicking in the hierarchy panel and selecting Empty Game Object. Rename this object to Enemy Formation and reset the transform. Open the timeline window by clicking the Window tab in the toolbar. Navigate to Sequence tab and select Timeline. I'll move the timeline window so that I can see the scene view and the timeline at the same time. Let's create a new timeline for our enemy formation by first selecting the enemy formation game object in the hierarchy panel. With that selected, click the Create button in the timeline panel. Let's rename this playable file Enemy Formation Circle Timeline. We'll start by animating the formation in a circular path. Make sure to add our enemy to our enemy formation. Now we're ready to start animating. Select the enemy formation in the hierarchy panel, and in the timeline window, click the red circle recording button on the enemy formation animation. The white marker represents the current time in our animation. Let's move the white selection marker forward 90 frames. If we change the transform of our enemy formation while we're recording in our timeline, the timeline will create a keyframe that remembers the current time in our animation and the current position of our game object. With our enemy formation selected, navigate to its transform in the inspector panel. Set the X position to -5 and the Y position to +2. Then let's move back to the first frame and add a keyframe by resetting the enemy formation to its original location. Then let's move forward 180 frames and set the X position to 0 and the Y position to 1. Again, let's move forward 90 frames and set the X position to -5 and the Y position to +2. Lastly, let's move it again 90 frames and set the X position to 0 and the Y position to +3. Now if we play our animation, the enemy formation will fly in a circle in our scene view. Let's make sure our formation continuously loops through this circle. Select the enemy formation game object in the hierarchy panel, navigate to the wrap mode in the inspector panel, and change the value from none to loop. Let's play our game. The enemy formation is flying a bit fast, so let's slow it down. Right-click the enemy formation animation in the timeline and select Convert to Clip Track. Now select the recorded animation, and in the inspector panel, navigate to the speed multiplier. Change the value from 1 to 0.8. Then let's run our game and see the effect. Now we're ready for our explosion animation. Let's create an empty game object by right-clicking in the hierarchy panel and selecting Empty Game Object. Name it Explosion and reset the transform. Open the animation window by selecting the Window tab in the toolbar. Navigate to Animation and click Animation. Move the panel so that you can access the Projects window and the Animation window at the same time. With the Explosion game object selected in our hierarchy, click Create in the animation window. Let's name this Explosion. Navigate to the Explosion sprite in the project file and select all of them by holding down the Shift key and selecting the first and last sprite. Drag them into the animation window. Select the expansion bar and drag out the sprite so there is about 15 frames between each. Copy and paste the last sprite. Move it 15 frames after the last keyframe. This will hold the last sprite for a small period of time, making our animation look a bit better. Next, we need to add a timeline component to the explosion game object. If the timeline window is no longer open for you, select Window from the toolbar, and in the upper left-hand side of the screen, navigate to Sequencing and select Timeline. With the explosion game object selected, click the Create button in the timeline window. Name the playable file Explosion Timeline. Right-click in the timeline animation and select Add from Animation Clip. Add the explosion animation to the timeline. Double-check everything's working correctly. Let's create a script that will destroy the explosion after it's finished playing. Right-click in the project panel and navigate to Create and select C# script. Name the script Explosion and double-click it to open it in Visual Studio. Add the Unity Engine Playables library to the beginning of our script. To destroy the game object, we can use the destroy function, using the keyword game object to select the game object this script is attached to. We'll make this explosion destroy itself after the timeline has completed playing. So we'll need to cast the return of our timeline duration as a float rather than its normal return, a double. Attach the script to the explosion game object. Now when we play, we can see the explosion plays once and then is deleted from our scene. Drag the explosion game object into the projects window, making it a prefab. Now that our explosion is a prefab, all we have to do is spawn a new explosion when our enemy dies. Double-click the enemy script to open it in Visual Studio and create a new public game object variable named explosion. To spawn this game object into our scene, let's use the instantiate function. Pass in the explosion game object variable and the current transform's position and rotation as parameters for this function. Select the enemy in our scene and drag the explosion prefab into the newly created variable for our enemy class. Now let's run our game and see our enemy get blown up. In the next video, we'll be building a variety of different gameplay features, like handling what to do when the user's won, sound effects, and much more.